Visiting the lonely planet Neptune once more? The most isolated planet in our solar system, Neptune is situated far from the other planets at the frontier of our solar system. Neptune is a really fascinating world despite its solitude. Neptune has received relatively little research because it is the last planet in our solar system. But there are a ton of opportunities for human exploration in the future. NASA and other space agencies have numerous missions planned to numerous locations throughout our solar system. What about Neptune, though? Can humans return to the planet in the next 10 or 20 years? What might the blue icy giant teach us about the history of the solar system? All of those and other topics will be covered in this video. The only planet in our solar system that cannot be seen with the naked eye is Neptune, whose atmosphere is made up of methane, hydrogen, and helium and gives it a bluish color. It is thought that the planet has a solid core that is encircled by an ocean of liquid water and ice. The Voyager 2 spacecraft's flyby of Neptune in 1989 marked the start of the planet's exploration and gave us our first up-close glimpses of its enigmatic atmosphere. On August 25, 1989, the NASA Jet Propulsion Laboratory in Pasadena, California, was bustling with activity. The previous evening, scientists, members of the media, and even rock legend Chuck Berry gathered at the facility's mission control to commemorate the moment the Voyager 2 spacecraft made its closest approach to Neptune, traveling less than 5,000 kilometers over the ice giant's North Pole. The degree of anticipation was really high. The anticipation as the spacecraft got closer to what is currently believed to be the Sun's farthest known planet had been growing for more than a year. Excitation increased day by day as Voyager 2 sent back photographs, gradually transforming a jumble of pixelated data into a massive, magnificent blue sphere. It came to the point where there were brand new discoveries on Earth every time a fresh set of photos was made public. The Voyager 2 was the first and only spacecraft to observe Neptune, marking a significant turning point in history. Each photograph captured by Voyager 2 showed an atmosphere that was extremely dynamic, complete with methane-rich clouds, fierce storms the size of Earth, and planetary winds that are faster than 2,000 kilometers per hour, the fastest in the solar system. For scientists, the information acquired during its flyby was vital. Voyager 2 discovered that the atmosphere of Neptune is composed of hydrogen, helium, and methane, and that the planet has a weak ring system encircling it. The fact that the rings had never been discovered before made it a significant finding. Nereid, Triton, and Proteus were among the moons around Neptune that were found. These moons were discovered to have ice surfaces, and Triton was proven to be the solar system's coldest moon. Neptune's enormous, frozen moon Triton was erupting with unexpected geysers and other signs of geological activity. The flyby of Neptune by Voyager 2 also helped researchers better comprehend the dynamics of the planet's magnetic field. The probe discovered that the magnetic field of the planet was tilted away from the planet's axis of rotation by roughly 47 degrees and was displaced from the planet's center by around 45 degrees. Since it was previously believed that each planet's magnetic field was centered there, this was a significant discovery. Voyager 2 then continued on, leaving Neptune alone, just as it had done with Uranus, the second ice giant in our solar system, after passing by it in 1986. Since then, scientists have continued to investigate and research Neptune's properties. A huge storm system resembling Jupiter's Great Red Spot was observed by the Hubble Space Telescope in 1994 on Neptune. Additionally, the Cassini mission gave us more precise pictures of Triton, the biggest moon of Neptune, as well as its atmosphere. Despite all of this investigation, there is still much about Neptune that we do not understand, and there are numerous possible topics for further investigation for upcoming missions. The origin of Neptune's Great Dark Spot, which may be connected to the planet's internal structure and composition, is one of the most fascinating mysteries. Examining Neptune's moons is another intriguing subject to investigate, as doing so might provide us additional knowledge about how the solar system formed. Future expeditions might send probes to explore Neptune's rings in addition to its atmosphere and moons. Although a large portion of Neptune's ring system is yet unknown, it is thought to be similar to Saturn's ring system. We may learn more about the formation and evolution of the solar system by comprehending the structure and makeup of the rings. Finally, missions in the future might possibly be dispatched to observe Neptune's auroras. The sun's charged particles combine with a planet's magnetic field to produce auroras, which can provide information about a planet's internal structure. We could learn more about the underlying structure and composition of Neptune, as well as the interaction between the Sun and Neptune, by observing its auroras. Future trips to Neptune, the solar system's most isolated planet, have a lot of fascinating prospective exploration targets. We may learn more about the genesis and development of the solar system as a whole if we can comprehend the structure, composition, and evolution of this fascinating planet. Fortunately, interest in exploring Venus is growing once more. Given the increased interest in planetary science and good scheduling, a second mission to these icy and unusual worlds may be launched very soon. That is not to say that research on Uranus and Neptune has not been done by scientists here on Earth. Astronomers frequently point the mirrors of massive telescopes on the ground and in space toward the edges of the solar system to investigate such far-off giants. But at such a distance, Uranus and Neptune look like tiny blobs. To better photograph them, a number of procedures have been needed. Scientists have performed experiments on Earth to learn more about the peculiar ice that exists inside these worlds, fired lasers into the night sky to improve their photographs, and studied Triton's atmosphere when it passed in front of a far-off star. These attempts, however, fall short. The issue is that, despite being technically possible, excursions outside of our solar system are difficult and require at least 10 years of preparation. When a mission can be designed and deployed in less than 2 years, things are a lot easier. Such brief missions can readily be funded, and they are also simple to construct and launch. Long-term missions, especially to distant objects, demand absolute precision, otherwise, the mission could be lost. Furthermore, when a spacecraft is far from a star, it cannot run on solar power and must instead use nuclear fuel like plutonium-238, which produces a steady supply of heat and is the ideal energy source for dark missions. However, NASA has not consistently purchased that radioisotope in the past. The rebirth of NASA's nuclear program could not have happened at a better moment. Starting off, there is no question that such a mission, after 3 decades of technological improvement and scientific discoveries, will revolutionize our understanding of the outer solar system merely by traveling there. Additionally, the planets will be aligned in the late 2020s so that a spacecraft headed for Neptune may receive gravitational assistance from Jupiter, allowing it to swing by the large planet and shorten the distance traveled by years. Finally, a trip to Uranus must depart before 2050 if we are to see the northern hemisphere for the first time. On Voyager 2's flyby of Uranus, the planet's southern hemisphere was the only illuminated region. The case for studying the ice giants of the solar system is strengthened by recent discoveries made by the Kepler Satellite Observatory. Astronomers are almost certain that ice giants, a distinct and unique form of globe as compared to rocky planets and gas giants, are the most common in the galaxy based on Kepler's examination of other planetary systems in the Milky Way. Without a thorough understanding of the Milky Way's most numerous inhabitants, we would unfortunately lack a concept of how planets are formed, develop, and ultimately die. But many of our most trustworthy models of planetary formation, which assert that such planets should have developed into fully fledged gas giants like Jupiter, but they didn't, and scientists aren't sure why, contradict the ice giants. The bulk of an average ice giant's interior is also thought to be made up of ice, hence the name, according to experts. However, certainty regarding this crucial characteristic is still lacking. Before we can fully understand exoplanets, we need to go back and finish the study for the ice giants because we know so little about Uranus and Neptune. Several missions to study Neptune and its moons are currently under consideration. The Neptune Odyssey mission, which is being examined scientifically, is the first of these. Triton and Nereid, two of the planet's moons, will be explored by this mission using a robotic lander. The lander will investigate the geology, chemistry, and atmospheres of these planets. Additionally, it will capture pictures of their surfaces, which will help us comprehend the makeup and interior structure of Neptune's moons. The Neptune Orbiter and Remote Sensing Project, which may launch sometime in 2035, is another suggested mission. This mission will research Neptune's magnetosphere, atmosphere, and moons using an orbiter and a lander. The lander will investigate the moon's surfaces and look for signs of potential life. These suggested missions are merely the start. More expeditions to Neptune are probably going to be considered in the future. These could consist of robotic probes to examine the surface of its moons, as well as flybys, landers, and orbiters. All of these missions will give us more in-depth knowledge about the makeup and conditions of this isolated planet, as well as improved understanding of this far-off, enigmatic planet and its moons. Despite being the most lonely planet in the solar system, Neptune will soon be a lot less lonely thanks to the planned missions. These missions will give us hitherto unobtainable details on the atmosphere of this far-off world and the possibility of life existing there, in addition to aiding in our understanding of it. What do you think of Earthlings going back to Neptune? Is it past time for a mission to the blue frosty giant? Share the video with your friends and let us know what you think in the comments section down below.